In the previous video, we talked about the shortcut method, how to decompose a rational function when the denominator is quadratic. In general, use these two. When the denominator is quadratic, which can be factored like ax plus b times cx plus d, and the numerator is just constant. And then when numerator has x. So 1.1b and d are general cases, and sometimes you have to put those two together in a single problem, kind of like this one, problem 2.1c. So here we go. We have 3x, and then we have just 1, and this one follows 1.1d, and this one follows 1.1b, and then we have two different decomposition to partial fractions, put them together, and we have something like that, and in the end we have two logarithmic functions. Certainly better than setting up the system of linear equations and doing all the hard work. Okay, this is the end of the shortcut for the quadratic denominator that can be factored. What if it cannot be factored? Well, in that case, we have to work out either this formula or that formula. The simpler case, if we do not have the linear term, x squared plus a certain number, in that case, we have this arctangent function. If you have x squared minus a positive number, that can be factored. So this kind of thing doesn't apply. For example, if you have x squared minus 5, in that case, this can be factored easily by x plus square root of 5, x minus square root of 5, and we can use this formula over here, 1.1, and you can find out the decomposition by partial fraction. It's gonna be what? 1 over 2 square root of 5 and 1 over x minus square root of 5 minus 1 over x plus square root of 5. I think that's the answer. Let's see. 5. I think that's it. Okay, this is just a number, and then this will generate a logarithmic function, and that'll generate a logarithmic function. So if you have x squared minus some positive number, no problem. Even if this is not a square number, no problem there. Now, if this is plus a positive number, then nothing like this will apply. What do we have to do? We'll have to use this 1.2a, and the answer will be arctangent function, not logarithmic function, but arctangent function. What if we have linear term? In that case, we'll have to use formula 1.2b. We have to take decomposition by complete square in denominator and then apply the formula, and then here it is. Let's go through an example problem, and here it is. 2.1d. So we have linear term, so we'll have to use the decomposition by complete square. So let's decompose this 3 into 1 plus 2, and then the left hand side, x squared plus 2x plus 1 is a complete square, so we have x plus 1 total quantity squared, and this 2 is nothing more than square root of 2 squared, so we can use the previous formula there, 1.2b. So b value there is square root of 2, so we have square root of 2 here and square root of 2 there. And we can verify that with Mathematica, and then we have arctangent, and okay. So we went through a bunch of examples where the denominator is quadratic. If it can be factored, then we can use these two shortcuts. If it cannot be factored, we can use this one. Some simpler cases, when we have monic, then we can use these shortcut A, C, and this A. And that's about it, as a matter of fact. I probably will not write any problem that goes beyond these in exams or quizzes or writing assignments anywhere, as a matter of fact. I'd rather go through with these quadratic cases with some other kind of applications that you have to use your brain, rather than those tedious problems that we are going to deal with only in classroom in the next segment of the video. What kind of applications am I talking about? Something like this one. We have transcendental functions, exponential functions, but how do we deal with those? Well, if you look at exponential function there, e to the x and e to the 2x power, so denominator is actually quadratic. So it can be factored, and if we can use similar kind of argument, the decomposition by partial fraction, and then you'll be able to find out the antiderivative. How about this kind of problem? Well, the numerator is cosine, denominator consists of sine functions, so my first reaction will be substitution by y equals the sine of x, and then the numerator will be absorbed by dy computation, and then everything will follow from that point on. That looks pretty much straightforward. So we have something like this, and factor, and this is just nothing more than decomposition by partial fraction. No cheating, I want you to do these. How about this one? Again, by partial fraction using e to the x and e to the x squared, kind of like this, e to the x squared, so it can be, the denominator can be factored like this, and then you can use decomposition by partial fraction. As a matter of fact, I use this AB and then set up the system of linear equations and do that, but actually it is possible to use this shortcut method here. And this is monic case, and then R value is -2 and S value is -1, so everything will work out if you use the formula, and in the end you're going to get these two logarithmic functions. Okay, let me close it quickly so that you will have time to do these problems. How about this kind of problem or that kind of problem? They look like far more complicated problem with x plus square root of x plus 1 and square root of x plus 3, but they will turn out to be partial fraction problems too. The typical technique is to substitute y as the square root. Kind of like this, y as square root, and dy will be something like that, and then x plus square root of x plus 1 is equal to y, so dx is 2y dy. And then put everything in, and you're going to end up with a rational function. What follows afterward? Pretty much standard. Decomposition by partial fraction using those shortcut methods that we went through over here. 1.1 ABCD or 1.2 AB. 1.1 ABCD are far more popular. They appear far more often. How about something like this? Again, the same deal. Start from the substitution as the square root, and then we have this kind of decomposition. And then how do we handle this decomposition? Again, I did it hard way here using the textbook method, setting up this A and B, but you don't really have to. You can use the shortcut method over here, this one, and then what is A, B, and C, and D, and then put those in, and you'll be able to find out the decomposition by partial fraction much more easily here. Yeah, this is really tedious. The shortcut is better. In the end, you're gonna get something like that. Let's see, is there any more? These are the kind of problems that you'll have to use integration by parts, and then out of nowhere the decomposition by partial fraction will come out. And this one is relatively straightforward, because if you use integration by part, arctangent function has strongest tendency to become u along with logarithmic function. So take the derivatives, you're gonna get 1 over 1 plus x squared, consequently generating a denominator. So no surprise there. How about this one? Again, if you use integration by parts, wait a minute, is this integration by part problem? It can be done with integration by part, but also you can decompose it using some logarithmic log rule, I think. Here I use integration by part, yes, and you have something like that, yes, and same for the next problem, I think, but I think you can use this kind of shortcut. X squared minus x minus 2 is the same as log of x minus 2 x plus 1, isn't it? Yes, consequently this is log of x minus 2 plus log of x plus 1, and I think you can avoid integration by part. Excuse me, I think you can avoid the decomposition by partial fraction if you use this method. Yes, integration by part will have to show up, because antiderivative of this will be an integration by part, antiderivative of that will be an integration by part, but partial fraction, I think you can get away with that. Okay, let me give you a little bit further hint. Dx is equal to that, and consequently that's equal to that, and then we have integral of sum, so we can decompose them into sum of two integrals, and then everything will take care of itself here. You're gonna have to use integration by part for this one and integration by part for the second integral, but those are standard integration by part, so you're not gonna have too much trouble there. Yes, this is gonna be a shortcut solution compared with this one, where you have to use integration by part, and then you have to use the partial fraction method in the end. This one, this is going to be different. Yes, this is going to be different because the inside cannot be factored. You see, x squared minus x plus 2 is irreducible, quadratically irreducible, so you will have to expect some arctangent function showing up somewhere. And well, I have a little bit of time, so let me show it very briefly and then just close it up. And yes, yeah, after a lot of hard work, arctangent shows up. Okay, no cheating. I'm gonna leave this kind of problem to students. And one more problem here, volume by cylindrical shell method. All you have to do is plug this one into cylindrical shell formula, 2 pi x times f of x, so we have something like this. And this one, it can be done by partial fraction method, and this is going to be a definite integral because this is a volume computation. Detail is left to the students.